Yeah. The next concept is the two-dimensional arrays, right? Previously we discussed about the one-dimensional array, which is allow the one element, which is allow the one set of elements. Okay, I think everyone knows the arrays definition. First, once again we will see the definition of the array. Array is nothing but a collection of similar data items, right? Okay, now the group of data items, same data type, like integer data type, like float, character, like that. So the two-dimensional array, now here two-dimensional array, see, these are especially for the matrix. What is the use of matrix? Remember, the main objective of the matrix concept is in database, we need a table. Okay, table means it is nothing but a combination of rows and columns. For example, now I want to take three columns like all ticket number, name of the student, and grade. We assume the number of students are, we assume now three students, nine students are there. Okay, now this is indicated. This is the first student all ticket number, right? All ticket number is first row 1. Now column 0, which is contain the all ticket number. Next row 1, column 1, which is contain the name. Row 1, column 2, which is contain the grade. So now table is nothing but a combination of rows and columns, as well as matrix is nothing but a combination of rows and columns. The main objective of two-dimensional arrays implementation, application orientedly, these are implemented in the arrays. These are implemented in the database tables, right? So now coming to definition of the two-dimensional array. Type name. What is type name? Okay, now I want to take the integer int. Now what is the name of the array? Same, previously we declared as a number of rows. How many rows are there in this example? 3 rows. How many columns are there? 3 columns. So number of rows are 3, number of columns are 3. So this is called the 3 by 3 matrix. So this is represent the first size is represent the row size is represent the number of rows, that is 3. Column size, that value is 3. So it is called the 3 by 3 matrix. Okay, now initialization, we have different initializations are there. Direct first initialization directly we have to take like this, and second initialization int a of 2. Now 2 means, what do you mean by 2? Number of rows are 2, number of columns are 2. A of 2, 1, 2, 3, 4. Right. The elements in this, the first element is actually it is represented like this. Actually these are all reside in our memory sequentially, but presentation of you, I want to take like this 1, 2, 3, 4. 1, 2, 3, 4. 2 by 2. The number of rows are 2, number of columns are 2. So this will be stored in our second memory. Now addresses are now. This is 0, 0, 0, 1, 1, 0, 1, 1. It means, now observe here. Now this is the 0th row, first one. 0, 1. Now what is the index of this 1? So 0, 0. What is the index of 2? 0, 1. Index of 3, 1, 0. Index of 4, 1, 1. You observe here. So the elements, when you are declare first initially this one, first one is the first one. Yeah, first element is 1, that is reside in like memory unit 4000, 4004, 4008, 4001 addresses. Okay, now what is the elements we have? 1. The second element is 2. third element is 3, fourth element is 4. Okay, one index is 0, 0, that is residing 4000 location, and two index, that is 2 index is 0, 1, that is residing 4004. 3, 1, 0, 4, 1, 1. Now, this is the one initialization. Same initialization int a square bracket, empty square bracket. The number of rows are not defined here, but number of columns are must. Number of rows are option, but number of columns are must. You have take the number of columns 1, 2, 3, 4. So 2 columns. Now how many rows we have? Number of elements are 4. So 2 columns we are mentioned, but automatically this will be take. Now one more initialization a of 2 to using with the square brackets, curly braces. 1, 2. This is the first row elements. This is the second row elements. So now one is a row, another one is column. Observe here. Another one is column. Now, what is row? 0. What is column? 0. What is row? 0. What is column? 1. So the size of this matrix is 2. Observe here. The size of the matrix is 2 by 2. So 2. Number of rows are 2. Number of columns are 2. Now, what is the condition here? First rows we are assigned what is the value? 0. And how many rows we have? Number of rows we have 2 rows. So 0 and 1. So always rows value is incremented by 1 because first row value is 0, second row value is 1. So automatically row value will be incremented by 1. Same way column is 0. Now column number of columns also 2. Now columns also increment by 1 because observe here this is 0th column, this is 1, and this is column 1, this is column the column 0 and column 1. So 0, 1, 0, 1 means number of columns also 2. So now we represented first size 1 is rows, second size of 2 is the columns. So now coming to the reading or printing of a two-dimensional array. Now already we know the single-dimensional array reading as well as printing. We completed some programs also. So how can we read the single-dimensional array? Okay, single dimension. Then we need only one for loop. For I equal to 0, I less than n, I plus plus, I plus plus. And now scan a percentage d comma ampersand a of I. That is for the single dimension. Now is it single dimension? No, two dimensional. One dimension, one loop variable is enough. But what about the two dimensional array? It's required two loop variables. So we should take two loops, like one is for rows, another one is for columns. Now I want to take example of the matrix simple reading program. So now read and print two-dimensional array elements. Observe here. Read and print two-dimensional arrays. So first we declare the two-dimensional array. Now what is the type of the variable data type? Integer. Int a of 3. Int a of 3 means we declare now 3 into 3, 9. 9 elements. 9 into size of the data type is integer. So 4. 36 bytes of memory is allotted for the A of 3. You remember this point. This is depends on the computer architecture, right? So now the size of the integer is 4 bytes. Then the number of elements stored in subscripted variable A, which contains 9 elements. So 9 into 4, 36 bytes memory is allotted for A. So where 36 bytes of memory is allotted? Where the 36 bytes sequentially available in that place is assigned. So now coming to when you are declare one first variable, I want to show here. This is the 0, 1, 2, right. Number of rows are 3. Again 0, 0, right. Now this is 1, right, and 0, 1, 2. 0, 1, 2, 0, 1, 2. Right, total number of elements are 3. So first we declare the variables, loop variables also required. I for we called for rows, J for columns. M is the size of the first matrix, Mn is the size of the matrix, size of the two-dimensional array. Okay, sometimes we have to read 2 by 2. Sometimes we have to read 3 by 3. So better you have to, your available space is there, 36 bytes. You have at most we are enter 9 elements. Right now I want to enter only 4 elements. That is called 2 by 2. Mn is the 2 by 2. 2 by 2 matrix. Right. Enter the elements. Now I want to take the 2 and 2. First test case 2. For I equal to 0, I less than. What is m value? What is n value? 2. So 0 less than 2. Condition is satisfied. This is the nested loop. And now when the outer loop is true, then enter into the inner loop. Now j value is 0, j less than also 2. Okay, now again condition is satisfied. Scanner. Ampersand a of 0, 0. A of 0, 0, we take like this. Better understandable. I want to take the this is 0, 1, 2. This is 0, 1, 2. Row-wise as well as columns. I rows 0 and 0. Now this place is called the 0, 0. Now it's set is 0, 0. What is the value? We are enter 3. Next, after statement, the outer inner loop is updated by 1. Updated. Okay. Inner loop is, if inner loop condition is failed, then outer loop is updated. J value actually 0. 0 plus 1, 1. J value is 1. So 1 less than 2, say 1 less than 2. Yeah, better you take 3 by 3. Sorry. Because here we have 3, 3. Okay. Now 1 less than 2, 1 less than 3. Yes, 1 less than 3. Actual condition is satisfied. So what is I value? 0. What is j value? 1. 0, 1. Ampersand. Ampersand means address of. Okay, that is start from the 4000, 4036. Ampersand a of 0, 0. Again, a of 0, 0 and I of 0, 1. 0, 1 we are enter element is 2. Now, after this, again, the condition is satisfied. That is called 2 less than 3. Now, j value, inner loop, outer loop is same. Inner loop is updated. Inner loop now values 2. 2 less than 3. Condition is satisfied. Ampersand a of 0 to we are enter. The value is some 5. Value is 5. Now, j value is updated. J is 3. 3 less than 3. Now, this condition is not satisfied. When this condition is not satisfied, then outer loop is updated. Outer loop is here, outer loop is incremented by 1. So now I value equal to 1. 0 plus plus 0 plus plus means 1. 1 less than. To write like this, 1 less than 3. Yes, condition is satisfied. Okay, now we are enter into the inner loop. Again, j value is 0. You observe here. If outer loop is updated, then inner loop is re-initialized to same value, initialized to 0. So j value equal to now 0. J value equal to 0. So what is the value? 1, 0. A of 1, 0. A of 1, 0. So we are enter element is 1. We are assume these are elements. Now j value is updated. Inner loop is updated. Inner loop is 2. Outer loop is 1. So inner loop is 1, sorry. 1 less than 3. Yes, condition is satisfied. So I value is 1, j value is 1. 1, 1. We are enter some element 6. Now outer loop is same. Inner loop is updated. Inner loop is now 2. 2 less than 3. Again the condition is satisfied. Right? Condition is satisfied. Then I value is 1, j value is 2. You observe here. I value is 1, j value is 2. We are enter some element 7. Now j value is updated. J equal to now 3. 3 less than 3. Again condition failed. When the condition is failed, then outer loop is updated. Now outer loop is now Outer loop is 2. Observe here. Inner loop is 0. 2, 0. Now both conditions are satisfied. 2, 0, of 2, 0, 2, 0. Where enter element is some 4. Element is 4. Then outer loop is same 2. Inner loop is updated. Inner loop equal to 1. 2, 1. 2, 1. Conditions. Both conditions are satisfied. A of 2, 1. 2, 1. Where enter element is 8. Next, outer loop is same, but inner loop is updated to 2. So 2 to the value is acceptable. So because the both conditions are satisfied, A of 2 to, so where enter the element is 9. Where enter the element is 9. You observe here, now J value is updated, J value is 3, 3 less than 3 condition failed. And outer loop is updated because inner loop condition is failed, outer loop is updated. Outer loop I value is also updated, I equal to 3. 3 less than 3 conditions are failed. So both conditions are failed. We are exit from the loop outside the loop. The control is directly jump from this line to here. Here, if you are interested, you print the values. So, printing how to print the values. So, one thing I will explain here. Now, how much time it will be taken? What is the time complexity of the reading of two-dimensional array? How many times this will be executed? How many times this will be executed? N plus 1 time. How many times this will be executed? N square plus 1 time. Which is the highest term here? N square is the highest term. So big O is the time complexity, big O of N square. This is the time complexity for the two-dimensional arrays. Now three-dimensional array, how many loops are there? 3 loops. So the time complexity is big O of N cube. Single dimension, big O of N. I will explain in one class for the data structure and the design algorithms. Yeah, I will explain briefly on time complexities. This is for the reading of two-dimensional arrays. Now you go for the printing of two-dimensional array. Look here, the printing of two-dimensional arrays. How can you print the two-dimensional array? See, same thing is repeated here. Okay, first I value equal to 0, I less than printf n. Why we are using this n value? Okay, this is for the next line. Okay, now you print what our previous elements are. Previous elements 3, 2, 5, 1, 2, 6, 1, 1, 6, 7, 4, 8, 7. So first I value j value. Okay, I value is 0, j value is 1. So now you have 0, 0. You have 0, 0, 3. Right. Now next element is 1. Maybe next element is, what is the next element? Not 1. Now element is 2. Element is 5. Okay. Now condition is failed. J value is 3. 3 less than 3. Condition failed. When the condition is failed, outer loop is updated. Outer loop is now 1. 1 less than 2 condition satisfied. Next line. You observe here. Go to the next line. Actually, we are here first. Now the control is jump from this line to here for the printing of other elements. Now 1, 6, 7 and again printf 4, 8, 9. This is the output. It is printing like matrix. Okay, this is the matrix. Okay, simple two-dimensional array reading and printing. Now, addition of two maps. How can you now, before this, we will take some example on the matrix. Simple example. I will share C++ want to execute one program on matrix. Where is the Dev C++? Yes. Now I think it is visible. I want to write the program. Write a C program to read and print 2D elements. hash include stdio.h, hash include stdio.h. No, it's line always in C programming. We start with the hash include. Hash include is the header file that responsibilities including IO, input output header files in our program. Now first to declare the variable. That variable is the variable is A of and size 3 and size 3. So now 3 by 3 matrix and loop variables I comma m comma n in previous program. So now printf enter size of matrix. Scanf percentage d comma ampersand a of I so we call so sorry, before this you have to size scanf percentage d comma ampersand m comma ampersand m. Printf enter array elements. So now I want to take the for loop for I equal to 0, I less than m, I plus plus. Open compound statement. For j equal to 0, j less than n, j plus plus. Only one statement here, no need of brackets. Close compound. This is for the reading of arrays. Better you have to take the comments. Reading of array. Of scanf just to printf. Now take some spaces 3. No need of ampersand symbol. Ampersand is for only reading. Okay, now here you take one printf statement because it will display like a array. Yeah. So, okay, now I think there is no errors in this program. We compile and execute this program. But before compiling, save the program. 2D arrays. Save as resource file. Okay, now stop sharing. Yeah. Look here. Enter size of the matrix. Now I want to enter 3 by 3 matrix. So the number of elements we are enter 9 elements now. 3, 2, 5 and 1, 6, 9 we assume. And next one is the 4, 5, 4, 7, 8, base 4, 7, 8. These are the elements. First element is the 3. That is index is 0, 0 index. Second element is 2. That index is 0, 1. Third element is 5. That index is 0, 2. Next condition failed. The control is jump to the condition is failed. Then when the condition is failed, then outer loop is updated. Outer loop is that is number of rows. Rows is increased. Row 1. Now 101, 116, 19, that is 9. And again condition failed. So rows are increased by rows are updated. So now row value equal to 2, 204, 217, 288. Now it will show like this. Now exactly it will print like matrix. If you are interested, then you take a brackets also, square brackets. This is about the simple program on two-dimensional reading and printing. Next, I will show one more program on matrix that is called the trace of the given matrix. I will write one more program here. Already you have a simple program reading and printing. Now I want to change this program. Right. Here I want to find out the finding trace of given matrix. Right. Now how can I write the program? Trace means sum of diagonal elements. Now for I equal to 0, I less than m, I plus plus, open bracket, for j equal to 0, j less than n, j plus plus. Now, sum equal to, we take the one variable like trace, trace equal to trace plus a of I and j. So before this trace, write variable comma, mn comma, trace equal to 0. That's it. Trace equal to 0. Now you print the trace value. Printf trace of given matrix equal to percentage comma take backslash ending with semicolon. Ending with semicolon. Right now I will execute this program. There is no need to save. Compile and run. Stop sharing. I think it is visible. Enter the matrix 3 by 3. Again, I want to enter 3 by 3. Now 3, what is that? 3, 2, 5, 1, 6, 9, and 1, 2, 3, 4, 7, 8. 4, 7, 8. Now see. 325, 169, 478. Now the sum of the trace of the given matrix. Yes. Actually, here you print the sum of the matrix. Now, what is the requirement? What is our requirement? Trace. What do you mean by trace? Trace is nothing but is sum of diagonal elements. But what did we complete? Now we have find the sum of the array elements. This is not correct. Okay, now this matrix, what is the diagonal we have? 3, 6, 8. So output is 8 plus 6, 14. 14 plus 3, 17. 17 is the output. But the value is 45. It is absolutely wrong. That's why just we have to change stop sharing. Yeah. Now go to the program. close. Yeah. Is there any condition required here? Tell me. Condition is there any required? Because I value equal to 0, j value equal to 0. The element is there. Now why we take the next element? 0, 1, why we take? 0, 2, why we take? And 1, 0, is there any requirement for 1, 0? No need. Just we need the diagonal elements. So you should write like this. Condition, you apply one condition. Both are equivalent. The I value, j value is equivalent, then we pick that element only. That is the condition. So I want to write here, if I equal to j, I equal to j, then you try to take the element. You take that element only. No need of 1 0, right? No need of 1 2, 0 1, 0 2, 2 0, 2 1. Only we take the diagonal elements only, right? Clear? This is the condition. Now I want to again stop sharing, close, yeah, stop sharing and execution. All of you look here, execution, right here. What is the value here? 3. Now you enter your own style. 1, 2, 3, 5, 6, 7, 8, 9, 4. 8, 9, 4. The matrix is 1, 2, 3, 5, 6, 7, 8, 9, 4. The trace of the given matrix 1 plus 0, 0 plus 6, 6 plus 1, 4, 4. So final value is 11. It is absolutely correct. So there is no doubt. So now sometimes ask this question with less time complexity. Here the time complexity is big O of n square for the finding of diagonal elements, sum of diagonal elements. Now we have to reduce the time complexity, so automatically the efficiency will be increased. So now we change the program logic with less time. The execution time is less. Now go to the program, we'll get the same output. Here there's no need of ij. Simple. I want to remove these lines. See, I want to remove these all three lines. First we take the trace equal to trace plus a of ii. Clear? There is no condition, there is no inner loop, only you need one outer loop. We take a of ii. See, find, compile and run. Printf trace, where is the trace? What is the error? Unknown variable. Yeah, okay, because here bracket. Remove that bracket. Compile and run. So stop sharing. Go to sharing. Yeah, this is the sharing. And now I think it is visible. Same 3 by 3 matrix. 1, 2, 3, 6, 7, 8, 8, 4, 5, 9. 4, 5, 9. We observe here. We reduce the size of the program as well as there is no for loop, there is no condition. Automatically, the time complexity will be reduced. 1 plus 7 plus 9. Okay, that is 8 plus 9, 17. This is the program for matrix trace. Okay, this is a simple program. Okay, I think it is understandable. Right now, matrix tracing is over, and next video I will share programs on matrices. Okay, thank you all. Please subscribe and share this video to your friends. Thank you all. Yeah, good evening all. Yeah, I think it is visible. Myself, Dr. Praveen, Associate Professor in SR University. Yeah, this is my email ID, p.praveen@sru.edu.in, and my mobile number also available here. So now today we will explain arrays concept in C language. Okay, I think everyone knows the concept of our previous concepts like conditional statements and control statements. In my previous videos, I explained operators, every concept in previous concepts like C language operators, conditional statements, control statements, and basic concepts of basic programming and different programs in loops. Okay. See, the concept is today I will explain arrays. What is array? Why we are learning this concept? What is the advantage to use this concept? Okay, actually we know simple programming. Why we are moving from simple programming to arrays program? See, already we discussed in normal program and controls. Why? What is the use of control statements? And now we will discuss arrays concept. See, observe here, students. When you are take a group of related items, like now you need some value like 15, and you need some element value, some 25, and you need some other value too. So the group of similar data items, group of similar elements, then we go for the arrays concept, because we don't want to create the more variables. We create only one variable. That variable is called the subscripted variable. See, observe here. Now I want to explain one concept before this one. Suppose you want to read some elements. What are the elements you have? Like element is the one element is seconds. Like now I want to read some. I want to take 2, 34, 8, 99, and one more element is the 16. Now this is my set. Now without arrays concept, without array, suppose you don't know the array, how can you read these elements? Suppose I want to sum these elements. How can you find the sum of these elements? So without arrays, you should create different variables, individual variables. This is called A. We are assigned value 16. We create one more variable B. We are assigned 2. C. We are assigned 34. D. We are assigned 8. E. We are assigned 99. Okay, now here we have only 5 elements are there. Suppose I have 100 elements. Now I have 100 similar elements like integer elements. Can we declare 100 variables? Is it possible? I think it is not possible. Okay, that's why we have to create a one variable which holds 100 elements, which holds 100 elements. You observe here. We declare one variable which holding 100 values, 100 elements. That is the main importance of arrays. That's why we are moving from individual variables to array. Observe here, array. So the definition of the array is, it is a collection of similar data items. So here I mentioned here, an array is a group of related data items with consecutive memory locations that share the common name. And consecutive memory locations. Consecutive means It is a sequential. When you are declare 5 variables, instead of these all variables, we declare one variable like A. Now the data type is the integer data type because these are all the integer elements. That's why we have to create a integer data type. Always the array is represented with the square bracket. Now how many elements are required here? 5 elements. So we declare like int a of 5. So we allotted some memory to this variable. This memory is allotted only sequential. So for example, first integer required 4 bytes. Swan, nth integer also required 4 bytes. Now the size is the 5. So each integer occupied 4 bytes. So 5 into 4, 20 bytes of memory is required for our this example. So 20 bytes of memory sequentially allotted 20 bytes of memory for our subscripted variable A, like I want to show here. So this is the declaration. Now when you are declaring int A of 10, int A of 10 in memory management, you observe here, in memory management, for example, 4000 location is available. Now 4004 is also available. Swan 4036 is also available. The first value that is called A of 10 is represented A0 to A9 or A1 to A10. The indexes A0 that is reside in 4000. The first element is reside in 4000. That index is the 0th index. And A9 Swan A9 A9 is reside in 4036. The index is 9th index. The value is some value. For example, we are entered the value is 99. Okay, and 99 element is reside in 4036. That is the memory management for the array. Now, this can be categorized two types. Now, this can be categorized two types. One is actually it is called the derived data type. Okay, now in data types, we have primary data types. Another one is the secondary data types or derived data types. And one more is the user-defined data type. Now, the array is a derived data type or secondary data type. So now these arrays can be categorized up here. These arrays can be categorized two types. One is the single dimension array 1D and another one is the multi-dimension array. In multi-dimension array, it can be categorized two-dimension array and n-dimension array. 2D arrays and ND arrays. N means n-dimensional arrays. Okay, one-dimensional array representation is, you observe here, data type, variable name, of size. Okay, now here we have a direct syntax, but before syntax, we write before example, we write the syntax as data type, D type, variable of size. This is the syntax. Data type, variable of size, one type of syntax. Right, now, data type is the integer. Variable name is the A and size is 10. So which allows the 10 integers. And take one more example. Data type is character. Variable name is str. Str means string. Size is 10. Suppose you want to read your name. You want to read your name, then you go for this one. And character A of 10. This is also similar to the previous syntax, previous example. So this is the definition, syntax, and example. Now I want to move to another slide and take some more initializations here. Now we can initialize the elements of array in the same way as the ordinary variables when they are declared. Now ordinary variables here, it is a array name. Ordinary variables, how can you declare? Some value is assigned to the variable. 10 is assigned to the variable. This is the single value. Single value. which contains only one purpose. Now coming to arrays, it is nothing but a collection of similar data items. So we want to collect some elements. Now these elements are reside in one storage. That storage is called the array. So how can you declare type? Type means integer. Array name. What is the array name? Yeah. Now you are mentioned the size. Size, what is the size? For example, 5. Now list of elements, what are the list of elements? We declare here 1 to 5, but actually this is not correct. Actually it is correct, but we take some other elements. Now element is 11 to 35 and 41, 15. We assume like this. Because 1 to 5, so better you have take the control statement like for loop, but that is not proper example. But here int a of 5 equal to 11 comma 2 comma 35 comma 41 comma 5, the 15. These are the elements in the array. Now this is the one initialization. Direct value, actually it is called the static initialization. And int a square bracket, here we don't want to specify the size, right? But we have elements. Size may be omitted, but depends on this element. This depends of this number. The size is automatically taken. Suppose here we have 5 elements, so size equal to 5. Here we have 10 elements, then size equal to 10. That is for the integer data type. And coming to character data type. Character data type always the last character is the null character. You observe here. Actually, what is the character array? Character array is nothing but a string. String is a character array. Character array. It is nothing but a collection of characters. Collection of characters. Now, what are the characters we have? A, B, C, D. 5 characters are there. Now, the ending character is the null character. This is the syntax for the strings. Now, I want to move. Now, how can you read and how can you print the single dimensional array elements? Now, here we declare the 5. We take some elements here, assign some elements. So, when you are directly assigned the elements, there is no need to read, right? And when the values are available here, 0th index. What is the 0th index? Element is 1. So, I value is updated. I equal to 0, 0 less than 5. Condition is satisfied. Then statement is executed. After statement, updation will be occurred. Updation is I++. So now I want to take the set. This is something 0, 1, 2, 3, 4. Because I equal to 0, I less than 5. Now the set, we take some set. A of I equal to 10, 3, 74, 9, 51. We assume this is the set. Now when you are assigned the values, 10 is here, 3 is here, 74 is here, 95 is 9 is here, sorry, 51 is here. So the index address is 4000, 4004, 4008, 4012, 4016. These are the addresses. See, observe here first. This is called index. This is called value. This is called address of the value. Okay, now what is the variable name? A of 0, A of 1, A of 2, A of 3, A of 4. Clear? Now for I equal to 0, I less than 5, condition is true. 0 less than 5, condition satisfied. Then automatically the control is jump to the body of the loop. A of 0, what is the value of A of I value equal to 0? I value equal to 0. A of 0, what is the value? 10. 10 is displayed on your screen. And after this statement, I value is updated. I equal to I+1. Now I equal to 0 plus 1, 1. 1 less than 5, say yes or no. Yes, again condition is satisfied. A of 1. What is A of 1? 3. Next, I value is updated. I equal to 2. 2 less than 5. Yes, again condition is satisfied. Print a percentage d a of 2. What is a of 2? Observe here, a of 2, 74. Next, again I value is updated. I equal to 3. 3 less than 5. Yes, condition is absolutely correct. Now a of 3. What is a of 3? 9. You print 9. And I value is updated. I value equal to 4. 4 less than 5. Condition again satisfied. So a of 4, then it will print 51. Now again I value is updated 5. 5 less than 5. Is it satisfied? 5 less than 5. Condition failed. When this condition is failed, then control is jump from loop to outside the loop. This is the simple program by directly printing the array elements. So now we are going to take one more example. This is the best example for the reading array elements and printing array elements. Now, how can you read array elements? How can you print array elements? First, we declare the array. See, this is the declaration of the array. A of 10. So, index is now the number of elements 10. Okay. I is the loop variable. N is the size of the array. Now, enter the size of an array. Yeah. Now, we want to enter only 5. That's enough. Don't take the 10 elements. Otherwise, if you are interested, you will take 10 elements also. Now enter elements. I equal to 0, I less than 5. A of, you observe here. When you declare A of 10, so the memory is allotted 40 bytes of memory. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear. Now address is 4000, 4004, 4008, 12, 16, 20, so on, 36, 4036. Clear. When you declare this variable, the memory is allotted for A, 40 bytes. And n equal to now 5. For I equal to 0, I less than n, 0 less than 5. Exactly correct. Ampersand. What do you mean by ampersand? Address of A of 0. What is the address of A of 0? 4000. Now the control is jump to 4000. We enter some value. That value, suppose value is 3. 3 is reside in 4000 location. Again, I value is updated 1 less than 5. So A of 1, ampersand A of 1. What do you mean by A of 1? 1 means address, base address is 4000. Observe here, you calculate like this 4000. Now I value equal to I into size of D type, size of integer. So 4000 is the base address. I value is 1. 1 into size of integer 4. So 4000 plus 1 into 4, 4004. The second element is resided here. We are under 10. Again, I value is updated. I equal to now 2. Ampersand A of 2. A of 2 means, what do you mean A of 2? 4000 is the base address. 2 into 4. So 4008. Third element is reside here. Continue until condition fail. Yes, now the elements we have. Now how can you print these elements? So simple. Go to the for loop. If you have single for loop, single dimensional array, then you go for the single for loop. 2-dimensional array, then you have take 2 for loops. N dimensional array, then you should take the n. That's important. Okay, I will show with some examples. Now, printf I equal to 0, I less than n, I plus plus a of I. A of I, what do you mean by a of I? A of I means a of 0, a of 1, a of 2, so on, a of n. That is the program for the to read and print array elements using with the single dimension array. Is it clear, guys? Okay, I think it is very easy program. And now we take the elements, right? You print the array elements, common code for single dimension array, it is visible. And now sum of array elements, sum and average of array elements. So it is also similar to our previous program. Now you know the simple program, right? With simple, I will show some programs using with arrays. See, this is the biggest element and the smallest element in the array. And here we have take the elements in reverse order, right? Elements, we are inserting the new element in array and we are removing the element from the array, right? These are all the simple and easy programs in arrays. Already here I want to show the memory management, how the elements are reside here. So A of three elements read means now base address is 1000 plus. Now 2 into 3, right? 1006. 2 into 3, that is called the 1006, right? Okay, size of integer is 2. Actually, size of integer presently minimum 4. So 4 into 3, 1012, because 3 is the index, right? This is the another program. Now we have a this for two-dimensional array. Now I want to show some programs on single dimension array. Wait few minutes. Stop here. Now I think it is visible. Dev C++ is visible. So I have to write the program here, write a comment, write a C program to read array elements and find their sum and average. Find their sum and average. So hash include stdio.h. Now main, always execution starts from the main. We know the hash include std. Hash is the preprocessor. Include is including the header files, that is called the input output header file in your program. So the input output header files are very important for execution because they required input functions and output functions. So now I want to declare a of 10 like previous program, comma I comma n comma sum equal to 0, right, semicolon, and float average. We calculate average of printf, enter size of array, enter size of array, scanf percentage d, comma, ampersand n. Formally we are using n. Now printf, enter array elements. Now for I equal to 0, I less than n, I plus plus. We need only one statement, so directly I want to write here scanf percentage d, comma ampersand a of I, ampersand a of I. Done. Okay, now for loop is reading is over. So now I want to print the array elements before find the sum. Printf sum equal to the array element array element. I equal to 0 I less than n I plus plus. Printf percentage 3D, we take the three spaces between one element to another element. Yeah, right. Reading and printing is over. After you have take the separate. Okay, now the next task is you have to find the sum of array elements. Now print, no need of printer for I equal to 0, I less than n, I plus plus. Now sum equal to sum plus or shorthand is acceptable. Yeah, I shorthand addition. So sum equal to sum plus a of n. Now printf sum equal to percentage b comma sum, and you print the printf average equal to percentage f. Why you are using f? F for floating point. Now sum by, again here we have small error. I will show. Yeah. Now this is the program for sum of array elements. You save the program before execution. Save execution. Okay. Sum. Save it to the program. There is no errors. Stop sharing. You see this size of the array. Again, you take the 5. Enter the array elements 3, 10, 7, 30, 46. Yeah. Now 3, 10, 7, 10, 46. Sum equal to 96. The average equal to 0.0000. Already I said here we have a small error. So why this error is occurred? See observe why this error is occurred. We check the program once again. We need the external typecasting. So actually 10, 30, 20, 50, 96. 96 by 5. How many elements? 96 by 5. So almost 19 point, 19 point somewhere, right? 19.1110. So, but the output is 0.00. So we will check the program here. Now, average equal to, we go for here. External typecasting. So then we'll get the output. 1 second. Yeah, stop sharing. One second, we will execute the program first. Compile and run. There is no error. Stop sharing and yeah. So here Now enter size of the array 5. I want to enter again 5. Now 3, 10, and maybe what is the next number? Yeah, no problem. 12, 54, and 7. 3 plus 2, 5. Now 96, 86. Okay, the sum is 86. Now average equal to 86 by 5. 86 by 5, that is called 17.20. Exactly we get the output value, right? 86 by 5, then you will get 17. 17 5 is 85, right? And 20. This is the output for our program. Now stop sharing. Stop sharing. Okay. And next we will take the some other examples on single dimension array.